Assalamu alaikum ji. This is Saad Shahid, and in this video we are going to cover the multiple choice questions from 9701 May June paper 2020, and this is variant 1 paper 1. So let's have a look on the question number 1. Ethene can be oxidized to form epoxy ethane, which set of conditions gives the greatest yield of epoxy ethane at equilibrium. So when we want to increase the yield of epoxy ethane, it means what we want? The reaction should move in the forward direction. So at equilibrium, there are two factors mentioned here in this question. Because whenever the pressure increases, reaction always move from greater number of moles to less number of moles. So on the reactant sides, you can see there is 1 mole and there is half mole of oxygen. So in total, we have 1.5 moles of the reactants, and on this side we have only 1 mole. So by increasing the pressure, reaction will move in the forward direction, and for the temperature the delta H is negative, so it means the reaction is exothermic. So exothermic reactions are favorable at low temperatures, so here we have option A, that must be the answer. Let's start solving this question number 2 now. Cobalt can form the positive ion. Here we have this ion, cobalt. We have 4 ammonia. Ammonia molecule is not having any charge on it. So there are 2 chlorine atoms as well. Chlorine is having -1 charge. That is the oxidation number of chlorine. So overall charge of this ion is +1. So let's solve this equation now. That is 0. That is -2 equals to +1. Cobalt equals to +3 in this way. So we have +3 in the option C. So that is the answer. So here we have question number 3. When considering one molecule of ethene, which row describes both the hybridization of the atomic orbital in the carbon atoms and the overall bonding? So we have a molecule of ethene here. So there must be carbon-carbon double bond, and both carbons are having 2 hydrogens. But remember this point, whenever there is a double bond, the first bond is sigma bond and the second bond is pi bond. And whenever there is single bond, it is always sigma bond. So here we have total 5 sigma bonds and 1 pi bond. So as far as concerned with the hybridization, remember this point, whenever there is a double bond in between the two atoms, the hybridization must be sp2. So in this way, the B is the correct answer. All right. So let's have a look on the question number 4 now. 10 centimeter cube of ethane is burned in 45 centimeter cube of oxygen. So this is the complete combustion equation. So let's have a look on the equation now. Ethane is C2H6. When it reacts with the oxygen, actually it burns in the presence of oxygen, so it produces carbon dioxide and H2O. So here we have 2 carbons in ethane, so there must be 2 carbon dioxide. 6 hydrogen atoms will give you 3 H2O. So what is the total volume of gas? This is what we have to identify, total volume of gas, when the reaction is complete under same condition. So here we have a gas, this is also a gas, carbon dioxide is also a gas, and H2O is formed, that is also a gas. We have to find out the volume of the gas after the reaction. So initially we are having 10 centimeter cube of ethane. Before that, we have to balance this equation by putting 7/2 here. So according to this, what should be the molar ratio here? That is 1:3.5 of the oxygen and 2 moles of carbon dioxide and 3 moles of H2O. But see, there is a rule, volume is directly proportional to number of moles. So if we have 1 mole, and for the ethane we are having 10 centimeter cube, So beta ji, for 10 centimeter cube, there must be 35 centimeter cube oxygen will be used for this combustion process. That will give you 20 centimeter cube of carbon dioxide and 30 centimeter cube of H2O. So in this way, in the beginning, we were having 45 centimeter cube. So 10 centimeter cube of oxygen is left behind, and these are the product formed. So after the reaction, we are having 50 centimeter cube of the gaseous product and 10 centimeter cube of this remaining oxygen. So in total, we are having now 60 centimeter cube of the gas. All right. So let's have a look on this question number 5 now. Two reactions are shown here. H2 is converting into 2H. Carbon monoxide is burned in the presence of oxygen and produces carbon dioxide. If molar amounts are used, how can the two energy changes associated with these reactions be described? Enthalpy of atomization and enthalpy of combustion. Beta ji, H2 is converting into 2H. This is not the atomization. For the atomization, you should remember 1 mole of atom should be formed. But here you can see there are 2 moles of hydrogen atoms are formed. So this is not enthalpy of atomization. All right. Enthalpy of combustion. Yes. The second equation you can observe carbon monoxide is actually burning, is combust in the presence of oxygen and produces carbon dioxide. So yes, this is enthalpy of combustion. As I have described, this is here we don't have enthalpy of atomization and enthalpy of formation. Formation means the compound that is formed from its constituent elements. So carbon dioxide is formed from the carbon and oxygen, not from the carbon monoxide. So this is not the formation. Bond energy. Bond energy means if we are having hydrogen, so the bond is broken down, the covalent bond is broken down and the atoms are formed. So we are observing that this reaction is giving you some insight about bond energy, yes, and enthalpy of combustion we have already discussed above. Carbon monoxide is showing you the combustion process here that is converting into the carbon dioxide. Yes, enthalpy of combustion is also observed in the above two equations. So C must be the answer. So let's start solving this question that is related to the Boltzmann distribution curve for the molecules of the sample of the gas at two different temperatures. Which letter on the axis represents the most probable energy for the molecules of the same sample of the gas at the lower temperature? But as you remember this point, on the y-axis we are having number of molecules, and on the x-axis we have energy of the molecules. Examiner is asking about the same energy. This is the probable energy of the molecules, and you are observing these two curves that is representing two different temperatures, that is considered T2 and this is T1. Remember this point, whenever you are having the higher altitude, that is representing the low temperature, and the curve that is away from the y-axis like this one, it is giving you the information that the temperature is higher. And we know that at the higher temperature the particles are having high energy. So we are having high energy molecules at this point, and at the lower temperature the particles are having low energy. So we'll select the option C. In the question number 7, examiner is asking about the units of Kp for this specific reaction. Because Kp is related to the gaseous reactants and the products. So here we have carbon that is in the solid state. So we are not going to address this one. And let's try to make the expression for Kp that is having pressure of the hydrogen, pressure of the carbon monoxide, because these are the products. products over reactants. This is the formula I'm going to use here. That is H2O in the gaseous state. Pressure is having unit Pascal. Pascal into Pascal divided by Pascal, because all the reactants and products are having only 1 mole. So by simplifying this, we are observing that we are getting this one. That is actually the B option. All right. Here we have question number 8. In this question, we have to balance the redox equation, and they have mentioned we have potassium dichromate solution that oxidize V2 ion. So V2 ion is oxidizing here. Oxidation is taking place here, and this is actually the oxidizing agent Cr2O7. Oxidizing agent will oxidize other and reduce itself. So chromate ion is converting into Cr2 positive. So what is the oxidation state changes here? That is converting from +6 to +3. How this is +6? Beta, 2 chromium atoms plus there are 7 oxygen, to -14 equals to -2. 2 chromium equals to 14 minus 2, that is 12. 2 Cr equals to 12. Simplify this and you will get +6. In a similar way, V -6 equals to -1. Vanadium is having +5 oxidation state. So oxidation number changes from +2 to +5. So oxidation is taking place here, reduction is taking place here. Now we have to make the half equations. Cr2O7 is converting into Cr3 positive, and V2 positive is converting into VO3 -1. First of all, remember this rule. Whenever you have to balance the redox equation, you have to balance the atoms. So here we have 2 chromium atoms. So that's why I put 2 here before the chromium ion, chromium 3 positive ion. Here we have 7 oxygen, so we have to put 7 H2O molecules here. In this way, there are 14 hydrogen atoms. For balancing this, we have to put 14 hydrogen ions here. This one is chromate ion, so that is 2 negative. Now all the atoms are balanced. After balancing the atoms, we have to balance the charges. Here we have -2 and +14, that is equivalent to +12. On this side we have only +6. How can we balance the charges now? So I can write down electrons here, because electron is negative, so 6 electrons makes -6. So in this way we have +6 here and +6 here. So now the charges are also balanced. Similarly, we have to do the same thing on the right hand side. V2 positive is converting into VO3 -1. There are 3 oxygen atoms, so I have to put 3 H2O molecules here. In this way, there are 6 hydrogen atoms, so I have to put 6 hydrogen ions here. Now balance the charges. On this side, we have only +2 charge. On this side, we have -1 and +6. It is equivalent to +5. So we have to put 3 electrons here, so that it becomes -3 and +2 we can get on both sides. In this way, the charges are balanced. So, beta ji, we have to find out the ratio of A and B. This is A and this is B. Now there are 3 electrons and there are 6 electrons. So I have to put 2 here so that electrons can be balanced on both equations. Okay? In this way, we are having 2 V2 positive ions, 6 H2O, 2 VO3 negative, 12 H2 hydrogen ions and 6 electrons after multiplying with this. So here we have 2 and here we have 1. So answer should be B, 1:2. Let's try to balance this redox equation now. In this question, we have chromate ion that is converting into Cr3 positive and V2 positive is converting into VO3 negative. We have to find the ratio of the A and B coefficient. These are the coefficients. So chromate ion that is having +6 oxidation state, which is converting into +3. So reduction is taking place on this side. And vanadium is having +2 oxidation number here. On this side, it is having +5 oxidation state. So the oxidation is taking place on this side. Let's write down the half equations. Chromate ion is converting into Cr3 positive ion. And on the right hand side, we have V2 positive, which is converting into VO3 negative ion. Beta, how can we balance the redox equations? First of all, we have to balance the atoms, then we have to balance the charges, and at the end, we have to balance the number of electrons. So let's try to balance the atoms first. There are 2 chromium atoms, so we have to put 2 here. There are 7 oxygens. For balancing the oxygens, I can write down water here. 7 water molecules are added to balance the oxygen atoms. But now we have 14 hydrogens on the right hand side. For balancing this, let's write down hydrogen ions on this side. Now all the atoms are balanced, but not the charges. Now we have to balance the charges. On this side we have -2. For the hydrogens we have +14. So the overall charge on the right hand side is +12. On the right hand side we have +6 charge. Water is neutral, so +12 and +6, they are not equal. So how can we balance this equation? We have to use the concept of electrons now. We have to add the electrons. 6 electrons are added so that the charges become equal. So now charges are equal on both sides, which are +6 and +6. This is the same thing we have to do on the right hand side. There are 3 oxygen atoms. So let's write down 3H2O on this side. In this way, there are 6 hydrogen atoms. So let's write down hydrogen ions on the right hand side. Now all the atoms are balanced. Let's balance the charges now. This is +2 and this is -1 +6, which is equivalent to +5. Now the charges are not balanced. So it means we have to use the concept of electrons. How many electrons we have to add on this side? 3 electrons, so that we can get +2 on both sides. Now the charges are also balanced. At the end, we have to balance the electrons. On the both side, do we have 6 electrons? No. So I have to multiply this whole equation with 2. In this way, the new equation will be V2 positive plus 6H2O, 2VO3 negative plus 12H positive and 6 electrons. So beta ji, we have to write down the coefficients only. There is only one coefficient with the chromate ion and 2 moles of the V2 positive. So 1:2 will be the answer. Let's have a look on this question now. A sample of argon gas has a mass of 0.2 grams at a pressure 100,000 Pascal and the temperature of 12 degrees Celsius. Which volume does the gas occupy? We have to find out the volume. We are given with the pressure, temperature and the mass. So let's use the ideal gas equation. PV is equals to nRT. By rearranging this, we can find out the volume, nRT over P. N is the number of moles. So we can find out the number of moles by dividing this value with the AR of the argon gas, which is 39.9. By dividing with 39.9, the answer will be, let me solve this, 0.005. This is the temperature. After adding 273, we can convert this temperature into the Kelvin scale, 285 Kelvin. Let's put all these values here in this formula. 0.005 moles multiplied by 8.31, which is the general gas constant, and the T is the temperature, that is 285, divided by 100,000 pascals. So in this way we can get the volume in meter cube. So let me divide with this value. Okay, so I am getting this result, 119 meter cube, but they have given the options in the centimeter cube. So beta ji, this must be the answer, 119 centimeter cube. This is the answer. Let's try to solve the question number 10 now. In which pair does each species have the same number of unpaired electrons? For this reason, we have to write down the electronic configuration. Aluminium has 13 electrons. So 1s2, 2s2, 2p6, 3s2 and 3p1. This is unpaired electron. Copper 2 positive. Copper is having 29 electrons, but copper 2 positive is having 27 electrons. So let's write down the electronic configuration of copper 2 positive. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. This is the electronic configuration of copper atom. When we are looking over the copper 2 positive ion, so the electron is removed from this side, from the s orbital, and one electron from the d orbital. So in this way, d orbital is having 9 electrons and s orbital is having 0 electrons. D is having 5 total orbitals, 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. First of all, we have to half fill these 5 orbitals, then they can completely filled. In this way, you can see there is again one unpaired electron. This is unpaired electron, similar to the aluminium. So A must be the answer. Let's solve the other other options as well. Calcium is having 2 electrons in the outermost shell. 3s, it is having total 20 electrons. 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. And chromium, which contains 24 electrons but 3 positive is showing you, okay, it is having 21 electrons. So 21 electrons, obviously if I will add one more electron, 3d1 will be written after this. Okay, so they are not having the same number of unpaired electrons, so that's why this is not the correct answer. So C and D are also not the correct answers. A must be the answer. Question number 11G. A sample of solid ammonium chloride decomposes on heating. Ammonia gas and hydrogen chloride gas are formed. A total 2.4 into 10 raised to the power 21 molecules of gas is formed. How many hydrogen atoms are present in the gaseous products? We have these two gaseous products, and it is containing these number of gas molecules collectively, 2.4 into 10 raised to the power 21. Both are having 1 mole. So ammonia gas is containing 1.2 into 10 raised to the power 21 molecules. Hydrogen chloride gas is also containing the same number of molecules. All right. But we have to find out the hydrogen atoms. In ammonia, there are 3 hydrogen atoms. So number of hydrogen atoms, that is 3 in ammonia. It is going to multiply with the number of molecules. And we can get 3.6 into 10 raised to the power 21. These are the hydrogen atoms in ammonia. And in the hydrogen chloride, there is only 1 hydrogen atom. So 1 into 1.2 into 10 raised to the power 21 atoms. All right. So collectively, it must be 4.8 into 10 raised to the power 21. C must be the answer. Got it? So here we have question number 12 now. A white powder is a mixture of sodium chloride and sodium iodide. It is dissolved into the water. In a test tube, an excess of aqueous silver nitrate is added. To the test tube, a precipitate X is observed. An excess of concentrated ammonia is added to the test tube containing X. After the test tube has been shaken, a precipitate Y is observed. Okay. So the question is related to the test for the halides. Let me write down the equation. We have silver nitrate, NaCl and NaI, a mixture of silver chloride and silver iodide. Beta ji, we can get the silver chloride, which is having white precipitate, and silver iodide that gives a yellow precipitate. Yellow precipitate, when added into the concentrated ammonia, beta ji, it would remain insoluble, and we will observe the yellow precipitates. The white precipitates in the presence of concentrated ammonia, it will dissolve. So white precipitates will disappear. So that's why I have to select the option D. Why is yellow? Because after adding the concentrated ammonia, it will dissolve and we'll only observe the yellow color at the end of the process. Now have a look on the question number 13. 6.9 grams of ammonium salt is heated with aqueous sodium hydroxide. The volume of ammonia produced measured under room temperature is 2.51 decimeter cube. But these are the reactants which ammonium salt is used: ammonium carbonate, ammonium chloride, ammonium nitrate and ammonium sulfate. We have to make a reaction with sodium hydroxide one by one, and they give this information that it is producing ammonia. All are ammonium compounds. When they react with the sodium hydroxide, we will observe the ammonia gas along with the salt, that is sodium salt, and all the sodium salts are soluble into the water. Now ammonia's volume is given to us, that is 2.51 decimeter cube at the room temperature. When we have room temperature and pressure, in that case we have to use 24 decimeter cube. So when we'll divide 2.51 with 24, we can get the number of moles, that is equivalent to 0.104. So beta ji, ammonium carbonate, in the ammonium carbonate we'll get NH4 twice carbonate, it will give you 2 ammonia. Ammonium chloride will give us only 1 ammonia. Ammonium nitrate will give us only 1 ammonia. And ammonium sulfate, it is also giving us 2 ammonia gas molecules. Its MR is 96. So beta ji 104, 0.104, if we'll divide this value with the ammonium sulfate, that is having here we have question number 23. 2-bromo-2-methyl-pentane is a tertiary halogenoalkanes. Tertiary halogenoalkanes. Which organic products are formed when 2-bromo-2-methyl-pentane reacts with a hot concentrated ethanolic solution of sodium hydroxide? So beta ji, if we'll look over the structure of tertiary halogenoalkane 2-bromo-2-methyl-pentane, 1, 2, 3, 4 and 5 carbons, 2 bromo and 2 methyl, there is one methyl group that is having CH3. Here we have CH3, here we have Br, here we have CH2, here we have CH2 and here we have CH3. Which organic products are formed when this compound reacts with hot concentrated ethanolic sodium hydroxide? So when it reacts with alcoholic sodium hydroxide, so beta ji, elimination reaction will take place. Br will remove from this side and H will remove from this carbon, or from this carbon. So these are three possibilities. So beta ji, let's make the products. CH2, C, CH3 will remain same, and here we have mentioned the double bond. CH2, CH2 and CH3 will form. So this is the first compound that is known as 2-methyl, because methyl group is attached with the second carbon, that is 2-methyl pent-1-ene, because the double bond is present at the first carbon. 2-methyl pentene भी लिख सकते हो और pent-1-ene भी लिख सकते हो. Now let's remove the carbon from this hydrogen. CH3 will remain same. This is the carbon. The bromine atom has removed from this side, and the hydrogen will remove from this carbon now. So it is left with one hydrogen. The CH3 will remain same. The CH2 after the CH, the CH3 after that. So beta ji, this compound is named as 2-methyl pent-2-ene. This is the second possibility. और अगर इस CH3 में से भी remove करते हो तो you will get the same first product. 2-methyl pent-1-ene will be the product. So let's have a look in the options what they have mentioned. 2-methyl pent-1-ene only. Is this only? No. We are getting pent-1-ene and pent-2-ene, so that's why the first option is incorrect. In the second option, 2-methyl pent-1-ene and 2-methyl pent-2-ene, these are the possible products. Yes, B is the correct answer. 2-methyl pent-2-ene is the only product. No, we have mentioned that there are two type of the products. 4-methyl pent-2-ene is not possible here. So again, D is incorrect. So B must be your answer. All right. Let's have a look on the question number 24 now. This is polypropene, that is an additional polymer. What are the C-C-C bond angles along its polymer chain? Beta ji, initially the compound that is having double bond and the carbon is like this. This carbon is having one hydrogen, this carbon is having two hydrogens like this. Here we have CH3. This is actually propene, in which जहां पे double bond है that is making 120 angle, but they are asking addition polymer का बताएं जी. Polypropene में
angles क्या होंगे? So let's try to draw the polymer of this. Double bond will break down, single bond में convert हो जाएगा, and the bond will open from both sides, and the product addition polymer will be like this. Here we have CH3, hydrogen, hydrogen, and hydrogen. All the all the atoms are making single bonds, so it must be tetrahedral in shape. Tetrahedral. And whenever there is tetrahedral shape, tetrahedral geometry in the molecule, so it will have a 109-degree angle. So A must be your answer. This is question number 25. An alcohol has a molecular formula C5H12O. It has several isomers, which isomer form a yellow precipitate with alkaline aqueous iodine. Alkaline aqueous iodine means, beta ji, we are going to perform iodoform test. Iodoform test. For the iodoform, remember this in the case of alcohols, because this is an alcohol. From the alcohols, remember this. बेटा जी primary alcohols में से only ethanol can give the positive test. Only ethanol. Or let me highlight one group here. This is secondary alcohol CH3COH and R group on this side. बेटा जी OH is attached with the carbon. It must have CH3 at one side. This is the condition. All right. Remember this point. OH is attached with the carbon. It must have CH3 group at one side. So that can give you the positive iodoform test. Whenever you will get the positive iodoform test, you will get this yellow precipitate in that case. All right. So we have 2,2-dimethyl propane 1-ol. So in this case, beta ji structure kya banega? That is propane 1-ol. So it is not going to form any yellow precipitate because only ethanol can give this. 2-methyl butane 2-ol. Let's draw the structure of this compound. 2-methyl butane 2-ol. So this is butane structure. 2-ol. So I am going to attach OH at this side. 2-methyl. So here we have CH3 group as well. Beta ji, this is actually a tertiary alcohol, not the secondary alcohols. So remember this point, tertiary alcohols cannot give the positive iodoform test. So that's why B is again the incorrect option, because this is tertiary alcohol. In the C option, we have 3-methyl butane 2-ol. 1, 2, 3, 4 carbons. 2-ol means OH is attached with the second carbon. 3-methyl means the methyl group is attached at the third carbon. So here you can observe the same type of pattern. OH is attached with the carbon that is having CH3 at one side. So beta G, this is secondary alcohol ki wo wali type that is having CH3 at one side. Okay? So it can give the positive iodoform test. In the last option, pentane 3-ol. 1, 2, 3, 4 and 5. OH is attached with this carbon. Beta, although this is secondary alcohol, but it has ethyl group on both sides. So that's why it cannot give the positive iodoform test. Hope so this concept is understood to you. Let's have a look on the question number 26 now. When compound X is heated, compound X is heated under reflux with the aqueous sodium hydroxide solution. Two products are formed, sodium ethanoate and hexane 1-ol. It means if we are getting alcohol and carboxylic acid salt, so the compound X must be an ester. This must be an ester group. So ester linkage किस तरह से होता है? Carbon CO O and R dash. All right. So beta ji, the bond is going to break down when we will use heat in the reflux, and we are adding sodium hydroxide solution in that, the bond is going to break down from this side. This O will get the sodium ion, and this R will get the OH group. NaOH is going to attach in this way. Alright. So if we have hexane 1-ol, it means at one side there must be 6 carbons. Alright. On the other side there must be 2 carbons. Sodium ethanoate, it means 2 carbons hone chahiye at one side, 6 carbons hone chahiye at the other side. So let's start from here. 1, 2 carbons are here, but that is attached with the oxygen. So beta ji, it is not going to form ethanoate group. Ethanoate में there must be CH3COONA. So we are not getting the same type of product here. On the other side, 1, 2, 3, 4, 5, 6, 7 and 8 carbons are here. So this is not the possible product. In the option B, we have 1 carbon, 2, 3, 4, 5, 6 and 7 carbons. So beta ji, from this side it is going to break down and alcohol will form in this way. So that makes heptanol, not hexanol. So B is again incorrect. In the C option, we have 1 carbon here, 1 carbon here, that is attached with the oxygen. So that is only giving you ethanol, not hexanol. So here 1, 2, 3, 4, 5, 6 carbons. So the bond is going to break down from here. It will form OH, and from the other side the Na will attach with this oxygen and ethanoic acid ka salt is formed here. So D must be your answer. Question number 27. What is the major product Z of the following reaction? You can see this compound and it is reacting with excess HBr. And we have to draw the major product. Beta, what is major product? The product that is formed after following the Markovnikov's principle. So what is Markovnikov's principle? Okay, the negative reagent goes to that carbon which has less number of hydrogen atoms. So in this case, this carbon is having actually has not any hydrogen, and this carbon is having one hydrogen. This carbon is having actually two hydrogens, so there is no hydrogen. So negative reagent is Br in HBr. Negative reagent goes to that carbon which has less number of hydrogen atoms. So here Br should attach on this carbon, hydrogen should attach on this carbon. We have excess of dry HBr. Excess है तो ये भी double bond टूट जाएगा. It is going to break down और यहाँ पे Br आ जाएगा on this side, and here it becomes CH3 actually. Okay, so here the Br is attached here, so that is minor product. So A must be the incorrect compound. B is following the Markovnikov's principle on both sides, so B must be your answer. Here you can see that Br is attached at this carbon जो कि Markovnikov's rule के against है, so C is incorrect. Br is attached here and Br cannot attach on this side because that is against the Markovnikov's rule, so D must be your incorrect answer and B is your answer. All right, okay जी, start हो गया जी. Here we have question number 28. The structure of the compound Q is shown. How many carbon centers are present in this particular molecule of Q? Beta ji, what are chiral centers? Chiral centers are those which are having 4 different groups at each side. Carbon must attach with the 4 different groups. So it means पहली condition याद रखें, whenever there is a chiral carbon, there must be no double bond. So double bonded carbon can never chiral. No double bond should be there. And the second thing which you have to remember, जहाँ पे दो same groups आ जाएं, no more than one hydrogen, no more than one hydrogen atom should be attached with that group, or no more than one alkyl group, okay, R group. So these are the few points which you have to remember. First of all, आप देख लिया करो कार्बन डबल बॉन्डेड है और हाइड्रोजन अगर एक से ज्यादा है तो डबल बॉन्डेड और एक से ज्यादा हाइड्रोजन वाला काइरल कार्बन नहीं हो सकता. Let's have a look in this compound. This carbon has two hydrogens, so it can never chiral. ये भी chiral नहीं हो सकता. This one is not chiral. This group is attached with the CH2 group. दोनों same groups attached हैं, so that can never be chiral. This compound is attached with the two hydrogens, so that's why it is not chiral. This carbon is attached with the CH3 group. There is one hydrogen. This group is different. On this side, this group is different. This group is different. So that's why this must be a chiral carbon. So this is your first chiral carbon. Let's have a look on this. On this side, it is attached with the different group. On this side, it is attached with the different group. So both groups are different. At one side, it is attached with this group. So that is again different. At one side, it has one hydrogen. So again, this is the chiral carbon. Beta ji, this is not chiral because there are two hydrogens. This is not chiral, there are two hydrogens. This one carbon has one hydrogen. This group is different. This group is different. And this group is different. So that's why this carbon is again a chiral carbon. This one is chiral carbon. This one is chiral carbon. This one is chiral carbon. This one has one hydrogen. This group is different. This group is different. And the third group is also different. So that's why this is also a chiral carbon. Let's have a look on this one. This is attached with the oxygen at one side. At one side, this is CH. On the other side, there is different group. At this side, there is one hydrogen. So this is also a chiral carbon. This carbon is having double bond, so that can never a chiral carbon. So बेटा जी कितने chiral carbons यहाँ पे हो गए? Let's count this. 1, 2, 3, 4, 5, 6 and 7. So we'll move with the C option. D option, sorry. Alright ji, so this is the question from the infrared spectrum. Compound X has an infrared spectrum as you can see here. But ji, what could be the identity of the compound X? For this question we have to look into the data booklet जिसमें mass spectrums की आपको different values given होंगी. For the ethanoic acid, this contains carboxylic acid group CO and OH. But when we'll look into the data booklet, we'll get the two peaks for the ethanoic acid. CO carbonyl group in the carboxylic acid has this value 1680 to 1730 per centimeter. And on the other hand, we have OH group. OH group will form a broader peak like this, that is having a value around 2500 say 3000 per second tak. So it will form a broader peak OH, and on the other hand the carbonyl group will form a sharp peak like this. This is sharp peak, this is broader peak. This one is a sharp peak. In ethanol, there is only one OH group that is attached with the carbon. So for this, अगर आप periodic table में देखोगे तो you will get the value that is let me have a look. This value is around 3200 से 3600. All right, 3200 to 3600 per centimeter. Again, this must be a sharp curve if we are having only alcoholic group. For ethyl ethanoate, that is an ester group. For the ester group, beta ji, that must be CO O group. सो इसकी वैल्यू अगर डेटा बुकलेट में हम देखते हैं, सो इट इज गिविंग यू अगेन अ शार्प पीक at around 1710 to 1750 centimeter per centimeter. And for the propanol, we are getting only one carbonyl group's peak, that is giving you a sharp peak around 1670 to 1740 sharp peak. We are getting this sharp peak in the above spectrum. We are getting this sharp peak in the above spectrum, but we are not getting this sharp peak at 3200 to 37. At here you are observing कि एक sharp peak भी है और एक broader peak भी है. That is only possible in the option A, so that's why A is your answer. In the C and D there is no broader peak, so that's why these could never be your answer. All right, now have a look on the question number 30. Which reaction produces an organic anion with a good yield? Heating ethane nitrile. Ethane nitrile means two carbons with the nitrogen group. When it reacts with sodium hydroxide, because that is heat under reflex with dilute sodium hydroxide. Actually यहाँ पे basic hydrolysis होने जा रही है, so it will give you CH3COONA, which is an actually salt. Salts completely ionize होके it will give you CH3COO negative and Na positive ion along with the ammonia. So we are getting this salt और ये ion उसमें. On the other hand, we have in the B option, we have again ethane nitrile that is reacting with dilute sulfuric acid. So we are going to observe acidic hydrolysis here. In the acidic hydrolysis, we'll get the ethanoic acid along with the ammonium sulfate, NH4 twice SO4. So this one is a weak acid which partially ionizes and produces less hydrogen ion and less organic anion CH3COO negative. So ज़्यादा yield तो बनेगी in the option A out of these two. C में देखते हैं जी, heating ethane with sodium metal, this reaction is not possible. In the last we have ethanol that is going to react with sodium hydroxide. Beta ji, alcohols, they cannot react with sodium hydroxide. This is again a test for the sodium hydroxide. ये टेस्ट नहीं शो करते, सोडियम हाइड्रोक्साइड के साथ रिएक्ट नहीं करते, whereas carboxylic acid can react with this and phenols can also react with this. So we have A option, that is the correct one. Betaji, for each of the questions in this section, one or more of the three numbered statements 1 to 3 may be correct. Decide whether each of the statements is or is not correct. The responses A to D should be selected on the basis of this table. अगर तीनों statements correct हैं तो A is your answer. If first and second statement is correct, B is your answer. Second and third statements are correct, so C is your answer. If only the first statement is correct, so D must be your answer. Let's have a look on the question number 31. Which terms can be illustrated by the equation that includes the formation of positive ion? Means cation. The first ionization energy, that is the amount of energy required to remove an electron. जब electron remove होता है तो obviously the cation will form, the positive ion will form, so that is correct. Heterolytic fission, beta, in the homolytic fission free radicals are formed. In the heterolytic fission ions are formed, cation and anion both are formed. So here the positive ions are formed again. Enthalpy change of atomization, so that is atomization, atom की formation है, तो that is not forming any positive ion, so we are moving with the first and second statement, so B must be your answer. This is correct, this is correct. Question number 32. Which molecules have no overall dipole moment? no overall dipole moment. Remember this. All the perfect molecules, perfectly trigonal planar molecule, perfect molecules उनको कह रहा हूँ which are not having any lone pair, BF3, AlCl3, SO3, from the AB3 type molecules, from AB4 type molecules, beta ji remember CH4, CCl4, these are few those compounds which are perfect molecules, and from AB5 type molecule PCl5, PF5. So these are few common examples from AB3, AB4 and AB5 molecules. They are not having any lone pair or all the atoms are same at each side. So that's why they will not have any dipole moment. So boron trifluoride यहाँ पे है. Boron trifluoride is an example of a perfect molecule, AB3 type molecule, BF3. So all the dipole moments are going to cancel out, so it is not having any dipole moment. So A is your correct statement. Methane is a perfect molecule, so it is not forming any dipole moment. Phosphorus pentafluoride PF5, that is again a perfect molecule, so it is again not having any dipole moment. So A, B and C, all the statements are correct. So beta ji, that's why we will move with the option A. All right. Question number 33. Carbon exists in several different forms. Two of these forms are Buckminster fullerene and graphene. Pitaji, which statements about Buckminster and graphene are correct? Both have delocalized electrons. Pitaji, in the structure of these both compounds, they are forming three bonds. Both of these compounds are forming three bonds. And the fourth bond is a pi bond. So that's why we will observe a delocalized electrons in both compounds. Buckminster fullerene has giant molecular structure. No, it is not correct because it has only 60 carbons in its molecule. So it is having a simple molecule and it has a simple molecular structure. It is not a giant molecule. So it is incorrect. The first statement is correct. The carbon atom in graphene form a tetrahedral lattice. As we just discussed, in graphene there is one pi bond. So beta ji, it cannot form a tetrahedral lattice. So this statement is again incorrect. So which one is your answer? Only one is correct. So D is your answer. All right. Question number 34. Carbon monoxide burns readily in oxygen to form carbon dioxide. What does this information suggest? The positive 4 oxidation state of carbon is more stable than positive 2 oxidation state. बेटा जी कार्बन डाइऑक्साइड में कार्बन का oxidation state is positive 4. How this is so? In carbon dioxide there are two oxygens, so that is -4, so this must be +4. In carbon monoxide we have one oxygen, so that is -2, so carbon must be +2. So जो ज़्यादा oxidation state वाला है carbon dioxide है, that is more stable. So that's why the first statement is correct. The standard enthalpy change of formation of carbon dioxide is more negative. So remember this point, whenever this is more negative, it means formation जिसकी ज़्यादा negative होती है, enthalpy of formation, when it is more negative, it means that compound is more stable. So carbon dioxide being a more stable molecule, it must have greater enthalpy of formation, and enthalpy of formation is negative. So beta ji, second statement, that's why it is correct. The value of equilibrium constant for the reaction, this is the reaction, is likely to be high. तो इक्विलिब्रियम कांस्टेंट की अगर बात की जाए तो Kc expression will be product over reactants. We have product, that is carbon dioxide. We have 2 moles of carbon dioxide here, 2 moles of carbon monoxide, and there is 1 mole of oxygen. So this must be the expression. So जब carbon dioxide ज़्यादा produce होगा तो obviously Kc value will increase. Value of equilibrium constant, that is actually Kc. So third statement is also correct. So A must be your answer. Question number 35. The catalytic converter fitted to the cars remove pollutants from the exhaust gases. Some of the reactions involve oxygen which comes from the air. Which pollutant in the exhaust gases will react with oxygen? Exhaust gases will react with the oxygen on the surface of the catalytic converter. Beta, the first option is nitrogen monoxide, dioxide. Beta, we know that nitrogen, K oxides and carbon monoxide, they are actually converting into the carbon dioxide and nitrogen gas respectively. Nitrogen dioxide will convert into nitrogen, carbon monoxide will convert into carbon dioxide. It needs oxygen, but nitrogen dioxide doesn't need oxygen. So I cannot select the first option. ऑप्शन स्टेटमेंट 2 को देखें तो अनबर्ड हाइड्रोकार्बन्स या अनबर्ड फ्यूल्स जो होते हैं दे नीड ऑक्सीजन so that they can produce carbon dioxide and H2O. So this reaction, this compound, this pollutant needs oxygen for the combustion process. Carbon monoxide has to convert into the carbon dioxide in the catalytic converter, so it needs oxygen so that it can convert into the carbon dioxide. So this needs oxygen. So second statement and third statements, these are correct statements. So that's why we should move with the C option. Alright. Question number 36. Chlorine reacts with sodium hydroxide in two different ways depending upon the temperature. Reaction 1. In the reaction 1, you can see we have chlorine that is having 0 oxidation state. Here we have -1 oxidation state. Here we have Cl negative, ClO negative 1. It means Cl को अगर आपने find out करना है, that is -2, that is equivalent to 1. Cl equivalent to 2 minus 1, that is plus 1. Here we have chlorine that is plus 1. So this is disproportionation reaction. And the second one is also self-oxidation and reduction reaction. Disproportionation reaction, which is called as self-oxidation and reduction reaction. The first reaction in which ClO is formed, that is with the cold NaOH. This one, ClO3, that must be formed by using hot NaOH or KOH, hot alkali. But why this is so? When we will use hot and concentrated sodium hydroxide, so it will do more oxidation. More oxidation की वजह से you will observe more oxygens here. ClO3 बन रहा है. But with cold NaOH, we will only observe one oxygen here क्योंकि less oxidation is taking place. Which statement about these reactions are correct? So first option में reaction number 2 at a higher temperature than at a reaction number 1, obviously because more oxidation is happening. The product of the reaction 1 shows chlorine in two different oxidation states. Yes, we can observe here the oxidation states as 0 to -1, 0 to +1. So that is disproportionation reaction. This is again the correct statement. And the last statement is the products of the reaction 2 show oxygen in two different oxidation states. Let's have a look. Here we have -1. Oxygen in two different oxidation state. Oxygen is -2 here, ऑक्सीजन इज -2 हियर. इन बोथ केसेस जो प्रोडक्ट्स हैं रिएक्शन 2 के, ऑक्सीजन की दो डिफरेंट स्टेट्स नहीं हैं बल्कि दोनों सेम हैं ऑक्सीजन की. So that's why it is not the correct statement. So first and second statement is correct. So which one is your answer? B. All right, B is your answer. Question number 37 now. In which of the following reaction is an organic compound oxidizes by the given reagent? CH3CHO, that is reacting with HCN reagent. तो बेटा जी ये तो एडिशन रिएक्शन होएगा, ठीक है. In which of the reaction is the organic compound oxidized by the given reagent? This is only the addition reaction. Oxidation नहीं होने लगी यहाँ पे. Second statement, this is aldehyde, Tollens reagent and Felling reagent. Beta ji, remember this. These are weak oxidizing agents. These are weak oxidizing agents which can do oxidation for aldehydes but not for ketones. So both reactions are possible in which aldehyde can oxidize. So second and third statement is correct. So that's why C must be your answer. Question number 38. When the apparatus is set up as shown, an orange precipitate forms. Orange precipitate forms in the test tube. Compound Q plus acidified potassium dichromate. On the other hand, we have 2,4-dinitrogen phenylhydrazine test. जो कि कौन से कंपाउंड शो करते हैं? All aldehydes and ketones can show this 2,4-dinitrophenylhydrazine test, which can give you the orange precipitate. All right, so let's have a look here. This is alcohol. बेटा जी primary alcohol की oxidation से we can get aldehyde, because here you are observing कि compound Q है, that is actually oxidizing here और aldehyde बनेगा. All right, this is primary alcohol. When it will oxidize, it will give you aldehyde, and aldehyde when reacts with 2,4-DNPH, it will give you orange precipitate. So that's why statement 1 is correct. For the second statement, we have this secondary alcohol. Secondary alcohol की oxidation से we can get ketones. बेटा जी कीटोन्स की जब 2,4-dinitrophenylhydrazine test करवाया जाएगा, so it will give the positive test with the orange precipitates. So second statement is also correct. In the last option, we have tertiary alcohol. This one is tertiary alcohol, and for the tertiary alcohol, remember this, it cannot show oxidation. टर्शियरी अल्कोहल की ऑक्सीडेशन ही नहीं होती तो आगे 2,4-dinitrophenylhydrazine के साथ कैसे रिएक्ट करवाना है? सो दैट्स व्हाई बी मस्ट बी योर आंसर. क्वेश्चन नंबर 39. Chlorofluoroalkanes that diffuses into stratosphere are broken down by ultraviolet radiation. Radicals are generated that cause depletion of ozone. What are these radicals? Chlorine radical, chlorine that is having fluorine H F, and on this side we have C. Which bond is going to break down? This one, and the chlorine radical will form, और बाकी आपके पास further it will attack on the ozone and that will form oxygen. Ozone deplete हो जाती है. Chlorine radicals actually they are going to break down ozone molecule. What are these radicals जो कि deplete करते हैं ozone को? याद रखें क्लोरीन का radical होता है. All right, chlorine radical, not fluorine radical, not alkyl radicals. Only the first statement is correct, so D must be your answer. सो जहाँ पे 39 कंप्लीट हुआ है 40 पे आया हूँ, वहां से कट करके 40 से स्टार्ट कर देना. सो हियर वी हैव क्वेश्चन नंबर 40. दिस इज द लास्ट क्वेश्चन. A mixture of three isomers of C2H2Cl2 is polymerized. So three isomers पहले हम देखते हैं C2H2Cl2 के कौन कौन से बन सकते हैं. So here we have the double bond. On both sides we have hydrogens. On both sides we have Cl in this way. ऐसा भी पॉसिबल है कि इफ वी लुक ओवर दिस कंपाउंड इन अ वे कि H यहाँ पे है और H ही यहाँ पे आ जाए, Cl यहाँ पे है और Cl ही यहाँ पे आ जाए. सो दैट इज गिविंग यू अ ट्रांस मॉलिक्यूल. दिस इज सिस alkene, this is trans alkene. And there is another possibility. जो थर्ड प्रोडक्ट बन सकता है वो किस तरह से बन सकता है कि कार्बन कार्बन डबल बॉन्ड हो, there is one hydrogen and there is one hydrogen as well here at a same carbon Clb दोनों एक ही कार्बन पे आ जाएं. So these are the three possible isomers. अब इनके combination से इस mixture से what are the possible isomers can form? बेटा जी if we'll combine just this molecule, double bond break हो जाएगा and it will form a continuous chain. So वो कौन सी possibility बन सकती है? This one. There is another possibility कि we can join these two carbons like in this way. एक chlorine है and there are three hydrogens. One chlorine and there are three hydrogens. So third could be the possible product, possible addition polymer actually. और अगर इस साइड को और इस साइड को अगर कंबाइन करवा दिया जाए, so बेटा जी there is another possibility कि three chlorine atoms हो और there is one hydrogen only like this in the first option. So all the three statements are correct. तो बेटा किसको select करोगे? 1, 2 and 3 are correct. So A must be your answer. With this we completed this paper 9701 May June 2020 paper 1 variant 1. अगर वीडियो पसंद आई हो प्लीज लाइक कीजिएगा एंड शेयर टू योर अदर फेलोज. थैंक यू.